Friends, my name is Eric Gregory, and on behalf of the Princeton University Public Lectures Committee, let me welcome you to this exciting event, The Man Who Knew Infinity, Bringing Mathematics to the Silver Screen. In conjunction with the Council on Science and Technology and the Department of Mathematics, tonight's panel is sponsored by the Van Uxem Lecture Series. This series was founded in 1912 with a bequest of $25,000 under the will of Louis Clark Van Uxem, the class of 1879, for the purpose of supporting public lectures at the university on subjects of current scientific interest. Previous lecturers in this series include Robert Oppenheimer, John von Neumann, Linus Pauling, Edwin Hubble, and Carl Sagan. Recent Van Uxem lecturers have featured Steven Pinker, Patricia Churchland, and Neil deGrasse Tyson. I'm particularly pleased to welcome Princeton's own Professor Manjul Bhargava to lead our discussion. Professor Bhargava is the R. Brandon Fradd Professor of Mathematics and Associate Producer of the film, The Man Who Knew Infinity. Manjul. Thank you.
Can you hear me all right? No? Can you hear me up there? Okay, well, thank you very much, Greg, for the kind introduction, and to everyone here for coming. It's really a great pleasure for us, Devika and Matt and Ed and Betsy and Tristine and I, representing the cast and crew of the film. We're so grateful for the invitation to be here and the opportunity to share this experience of filmmaking with you about the great Indian mathematician Ramanujan. 3 of the 6 of us here, as you can see, are Princeton alums, which of course makes this opportunity extra special for us. Before introducing the actual filmmakers, I was asked to say some words about Ramanujan and his life and his work. His work, of course, has influenced generations of mathematicians, including many mathematicians here at Princeton, and in particular in this audience. I myself am in that group. Ramanujan's life story has been an inspiration to so many aspiring mathematicians as well. His life story is really a very inspiring one. And so I want to tell you a little bit about that, and then I'll bring the filmmakers and we can talk about how we brought some of these things to the screen. So the first place where people got to know about Ramanujan in the general public, of course, mathematicians have known his story for a long time, and it's been a dream of ours to bring his story to the general public for a long time. But in the 90s, when Robert Kanigle's biography, The Man Who Knew Infinity, came out about Ramanujan, that's when he started becoming more of a well-known name. So this best-selling biography was written by Robert Kanigle. That's his picture there. And that's what the original cover of the book looked like. It looks a little different now. And ever since that book, it's been the dream of so many that this book could be made into a film, so that this amazing life story could come alive on screen. And so that dream is finally coming true. The Man Who Knew Infinity is also now the new Hollywood film about Ramanujan that's based on Robert Kanigle's book. Ramanujan is played by Dev Patel of Slumdog Millionaire fame. That's his picture there. And his collaborator is played by Jeremy Irons, his collaborator G.H. Hardy. His wife is played by Devika Bhise, who is here with us as well today. So Ramanujan's story, as I said, it's quite amazing. Ramanujan was born in 1887 in a small town near Pallipalayam in Tamil Nadu in southern India. So it was at the end of the 19th century during British colonial times. He was born and grew up in relative poverty. But he grew up in a very artistic house. For mathematicians, this is going to be a theme of the film as well. For mathematicians, mathematics is an art form. And the art form that was prevalent in his house was Carnatic classical music. His mother was a Carnatic classical singer. And so that was the environment in his home. wonder if we should close the door. It might not surprise you that Ramanujan was an outstanding student. He won many academic awards, earned a scholarship to college. But the mathematics classes that he encountered in school were, they didn't challenge him very much, so he did most of his mathematical exploration on his own. In particular, he discovered much of trigonometry by himself as a 13-year-old. And then he was a little disappointed when later on in school, he discovered that people already knew it. And this is something that happened to him many times during his life. As he entered high school and particularly college, he started to spend all his time on mathematics, discovering new theorems every day, sometimes many, many theorems in one day. And as a result of proving all these theorems, he flunked out of college twice. And so he would spend many hours in the temple lobby listening to drums, the drums called tabil. It's a Carnatic classical drum that he used to listen to while he did his mathematics. Again, there was this theme throughout his life that music inspired his mathematics. He also worked on mathematics a lot in his home, which he shared with 6 people. We often have this experience in the Princeton math department and probably throughout Princeton that people are like, we don't quite have enough office space to do our work. I have to share an office with somebody. Well, here he was in one room with 6 people living there and also doing his work and producing more theorems in one day than we wish we could produce in a year. He used to say that his findings came as visions from his hometown goddess, Namagiri. And some of the things he wrote down, this is still one of the best explanations we have for how he used to come up with this stuff. To alleviate poverty in his home, so his family lived in quite poor conditions. To help alleviate the poverty, he was a college dropout. He found a job as a clerk to help alleviate some of this poverty. And so he was, in the daytime, he was doing his clerical work to earn a little bit of money, but all free hours otherwise were spent doing mathematics. Yeah, the problem was, so he was producing some really amazing things, that we know that now, but at the time, nobody locally could really comprehend what he was doing. He was filling pages and pages with symbols and theorems, and there wasn't any expert locally who could understand what he was doing. His family, nevertheless, the things he was writing, people thought he was completely crazy. And he did have, however, the support of his family. His family believed in what he was doing. His wife and his mother really believed in him, that what he was doing was important. And his friends encouraged him to write to mathematicians around the world. If there wasn't somebody locally who could understand what he was doing, maybe someone somewhere else could understand what he was doing. And so he wrote many letters to mathematicians around the world. Most people would look at the letter and throw it in the garbage immediately, thinking that it's a crank. I'll show you some of the things he said in the letter, and you'd understand why people would immediately throw it in the garbage. So one of the letters that he wrote was to G.H. Hardy, who's the one person who did not throw his letter in the garbage. But we have the letter to Hardy. This is how he starts the letter. I beg to introduce myself to you as a clerk. Okay, that already, you're a professional mathematician and you're hearing from a clerk. I have had no university education. Okay, at that point, you can imagine most people what they would do with the letter. I have not trodden through the conventional regular course, but I am striking out a new path for myself. And the results I get are termed by local mathematicians as startling. So this piqued the interest of Hardy. So on the left there is a picture of Hardy, and on the right is Jeremy Irons, who plays Hardy in this film. Quite a resemblance. For all of us in this generation, I think we're always going to view Hardy as Jeremy Irons. Okay, so what was in the letter that piqued Hardy's interest? Well, here's something Ramanujan wrote in his letters. If people hadn't thrown his letter by this point, which they usually did, well, here is something, one of the first math formulas that Ramanujan writes in his letter. 1 plus 2 plus 3 plus 4 plus 5 plus dot, 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 forever. If you add all the positive integers, Ramanujan says you get minus 1/12. What on earth could that possibly mean? It's clearly a crank. Most people would throw it out at that point. However, Hardy recognized this immediately. There is a meaning to this, and if you ever get to take complex analysis here, some of you have, this is the theory of analytic continuation. There's a natural meaning that you can attach to the sum of the positive integers if you know complex analysis. It's the theory of analytic continuation of the Riemann zeta function. And this is something that Ramanujan discovered on his own. Of course, he had no education, no formal education, even undergraduate education. He had never learned complex analysis. So how on earth did he come up with this without knowing that entire field? Well, this is one of the mysteries that comes up over and over again when looking at his work. Somehow he could make these kinds of leaps that were several courses worth, several years worth, that he would arrive at in one line. But the fact that Hardy recognized this meant that Ramanujan had finally perhaps found someone who understood him and understood that the things he was writing were not crazy, but were in fact very deep. So that was one instance where at least Hardy knew what Ramanujan meant. And there were a couple other formulas that Hardy saw that he could prove, and so he thought, okay, clearly this person knows what he's doing. And then he would go a couple lines later, and there were things that were completely out of this world that Hardy could not fathom how one could possibly come up with that, let alone prove it. So here's one example, just to give you a flavor of some of the kinds of things that Ramanujan wrote in the letter. Ramanujan defined he loved infinite things. That's why he's the man who knew infinity in Robert Kanigle's book. He defined this fraction, but this fraction that goes on forever. So it involves a parameter q. R of q is defined as this infinite fraction, 1 divided by 1 plus q divided by 1 plus q squared divided by 1 plus q cubed divided by 1 plus, and so on, forever. And Ramanujan's question was, can you evaluate this? If you plug in a value of q, can we figure out what that is, that infinite expression? There's one particular case of this expression that was well known, very famous. If you plug in 1 there, you get 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus forever. And that's known to equal minus 1 plus square root of 5 over 2. That's a famous mathematical exercise that, well, if you're mathematically inclined, I encourage you to figure out. It's not so hard. The key there is that if you plug in q equals 1 there, then you'll notice that 1 over 1 plus, that thing that's left, is exactly a copy of itself. Right? If q equals 1, there's a copy of that fraction sitting inside itself. And so if you let that expression be x, you find that x is equal to 1 over 1 plus x, and you can solve for x. So that's, okay. So if you're mathematically inclined, you understood what that meant, and otherwise feel free to ignore it. So R of 1 was well known. That was a well-known fact, and it's a common exercise that we give to talented high school students today and to college students. But for any other value of 1, that trick that I just showed you where you have a copy of the fraction in itself, that doesn't work, because once q is not equal to 1, then there is no copy of the fraction inside itself, and nobody had any idea ever how to evaluate such a thing. So that was the question. Can anyone evaluate R of q for other values of q not equal to q equals 1? And Ramanujan claims in his letter that he can evaluate it by plugging in e to the minus 2 pi. And he says if you plug in e to the minus 2 pi, you get e to the 2 pi over 5 times this expression that kind of looks again like that same number, golden ratio. And this was just an amazing, for Hardy, who had studied continued fractions, this was just an amazing claim. First of all, they were plugging in things that involved pi and e, and then getting out things that involve e and pi and the golden ratio. This is, to a mathematician, is just a beautiful expression because e is coming together, 2.71828, this exponential constant. Pi, what does this problem have to do with circles? Pi is coming in here, and the golden ratio is coming in here. 3 of the constants that mathematicians love are all united in one equation here. And Ramanujan made another unbelievable claim that he could actually plug in e to the minus pi times square root of n for any rational number n into there, and he could evaluate it. This totally blew Hardy away because all these magical constants of mathematics were appearing all in one equation at the same time, and Hardy had no clue how one could ever come up with such a thing, let alone prove such a thing. So that was just to give you a taste of one of the first things that caught Hardy's eye and made him think there's something really out of this world going on here. And he believed, even though he had no idea how to prove such a thing or come up with this thing, he believed that it was true. Hardy's reaction was, these formulas defeated me completely. Hardy was one of the great number theorists of that time in the world. He was at Trinity College in Cambridge University. He's the first one not to throw out Ramanujan's letter. And when he looked at this particular formula that I just showed you, he said, these formulas defeated me completely. I had never seen anything in the least like this before. They could only be written down by a mathematician of the highest class. They must be true, because no one would have the imagination to invent them. And he was right. Hardy was so taken by these formulas, he immediately invited Ramanujan to come to Cambridge. This caused all sorts of commotion at Trinity College in Cambridge because, well, Indians were not usually invited to come during those times, but especially an Indian who had no education. But he did manage to invite Ramanujan to come to Cambridge, and they had one of the most productive collaborations of all time that their works still influence the mathematics that we do today in a major way. During his visit, Ramanujan wrote 30 papers, some on his own and some jointly with his mentor, Hardy. And a lot of these papers created revolutions in the areas that they were writing about, revolutions that are still occurring, actually. So that part was great, but Ramanujan had to overcome pretty serious hardship. There were difficulties of heavy racism. World War I was going on. And one of the major problems that he had was that he was a vegetarian coming from South India. Many of you can relate. English food is not so easy to eat if you like spicy food. But especially if you're vegetarian at that time, people had never really heard of what a vegetarian was. And so he had severe, really difficult problems in finding vegetarian food, and he started suffering from malnutrition in a major way. He was also not used to the cold weather. He was coming from tropical climate, coming to cold weather. That was also difficult for him, especially given his malnutrition. And the fact that World War I started when he was there meant that he couldn't go back home. And so he didn't even have the option of going back, nursing himself back to health with his wife and his family. And those were just not options. He was stuck there doing mathematics, which was incredibly productive, but there were these severe difficulties. Being an uneducated Indian in the midst of Trinity College was very tough. But despite these hardships, in just the 5 years that he was there for his field-changing work, he was elected Fellow of the Royal Society. The first Indian scientist ever to be elected, but this was considered the greatest honor that a mathematician could achieve at that time. And despite the racism troubles that he had, people had to, on his merit, he was elected Fellow of the Royal Society. But due to malnutrition, he fell very ill towards the end of his stay. At the end of World War I, he was finally able to return home. But the malnutrition led to tuberculosis, and he died 1 year later in 1920 at the young age of 32. This is one of those things that's really difficult for mathematicians to comprehend. One wonders, he had just hit his stride at the age of 32, proving remarkable theorems that were changing mathematics. And one always wonders, as a mathematician, how different mathematics would be had he lived to a normal age. It already is very different, just from the work he did until the age of 32. Even on his deathbed in his last year in India, when he returned, on his deathbed, he continued to produce mind-blowing mathematics, which is only beginning to be understood now, just in the last few years, and which we're still trying to understand today, and it's having tremendous applications as we're understanding it. So even today, his work, we're still understanding and applying to many mathematical as well as physical phenomena. So that's the story of Ramanujan. What are the things that we can learn from the story of Ramanujan? Well, first of all, it's his mathematical legacy. His ideas have inspired and continue to inspire generations of mathematicians, including here at Princeton University. They've played an important role in the works of Professors Conway and Sarnak and Wiles, Professor Zhang, Professor Skinner, and myself, and of course many of our graduate students and postdocs are heavily influenced here at Princeton by the works of Ramanujan. So his legacy seriously continues in a very serious way in mathematics. But there's a greater, broader legacy that Ramanujan leaves, which is the message that talent can really be found anywhere, even in the most unexpected places, regardless of economic status, regardless of background. And it's a story that really teaches us that it's very important for education to be available to the masses, to the poor, in every segment of society, because there is talent there, and it just needs to be found and fostered. And that's what universal education is so important for. And that's really a broad lesson that his story really teaches us. Okay, so I was asked, can Ramanujan's mathematics be explained to the public? And, well, in general, no. But there are three things that have actually really been important to mathematicians, and that can be explained to the general public. And I just wanted to mention those to you. So the first gem that I'd like to tell you is an area called partitions, and this is an area that's really talked about in the movie as well. So we say that P of 4, so here's the definition, we say that P of 4 equals 5. And why is that? Because we can partition 4 into pieces in exactly 5 ways. Let me explain. So you can take 4 and just not break it up. You get 4. 4 can also be written as 3 plus 1, 2 plus 2, 2 plus 1 plus 1, or 1 plus 1 plus 1 plus 1. There are 5 ways that you can break up 4, right? And so that's why we say the number of partitions of 4 is 5. In other words, P of 4 is equal to 5. That's all. Okay, so that's the partition function. So P of 1, you can think about it. P of 1 is 1, because there's no, 1 can only be written as 1, and that's it. P of 2 is 2, because you can write 2 as 2, or you can write it as 1 plus 1. Right? P of 3 is 3, because you can write it as 3, 2 plus 1, 1 plus 1 plus 1. Okay, well, you can keep trying P of bigger and bigger numbers. P of 8, 22. P of 16 is 231, you probably guessed that. P of 32 is 8349. P of 64 is getting bigger very fast, as you can tell. P of 128 is getting, everyone see the pattern? P of 256. Okay, well so the partition function is a very central function. This is very important. How many ways can you take something and break it up into parts? This is something that comes up in many branches of mathematics, and particularly in statistical physics. You need to know if you have a certain amount of energy, how many ways can it be broken up into the states that are there in the system. So this is a very important problem. But when mathematicians looked at this function, it looked completely mysterious. No mathematician could ever see a pattern in this. And it was a long time unsolved problem. How does P of n grow as n grows? So if you take partitions of bigger and bigger numbers, how fast does that grow? And this was a long time unsolved problem. In fact, lots of mathematicians have claimed that there probably isn't any natural function that would allow you to tell how fast this grows, allow you to predict how fast this grows. Well, this was a problem that interested Ramanujan. And, well, he wrote down such a formula. For the first time in history, Ramanujan came up with an asymptotic formula for P of n. In other words, how does P of n grow as n goes to infinity? And his theorem was that P of n grows like this. Again, something that involves e's and pi's. So P of n basically grows like 1 over 4n square root of 3 times e to the pi square root of 2n over 3. So e, again, is this fundamental number, 2.71828. And pi is the number that comes from circles, and they both appear in this formula. And this was proven by Hardy and Ramanujan, and it completely surprised all the experts at the time. And the proof that they gave of this formula, so not only was the formula very important, for example, in statistical physics, to understand how energy can be dissipated into states, but the method that they introduced to prove this is called the circle method, which today, so that this circle method was introduced for this problem, and today is the fundamental tool of analytic number theory, and is a tool that at least 3 of us here at Princeton use on a regular basis. And that originated from this problem on partitions, which is an elementary problem that anyone can understand. The proof, on the other hand, yeah, it's not as easy, yeah. But the statement, yeah, and what the problem is totally elementary. Another elementary work surrounding Ramanujan is a story that Hardy relates to in his book. I remember once going to see Ramanujan when he was ill at Putney. I had written in taxicab number 1729, and I remarked to him that the number seemed to me a rather dull one. No, he replied. It is a very interesting number. It is the smallest number expressible as the sum of two cubes in two different ways. This was very typical of Ramanujan. It led Littlewood, one of the other collaborators there at the time, to remark that every positive integer was a personal friend of Ramanujan. Amazingly enough, these kinds of numbers that are the sums of two cubes in two different ways have now been heavily studied in many, many papers. They're called taxicab numbers after this story. And it's actually, this problem has led to all sorts of amazing mathematics. Okay, the last thing I'm going to tell you is not really understandable. And don't feel bad about it. I'm a mathematician in this area, and I don't understand it either. The last letter that Ramanujan wrote to Hardy said, "Dear Hardy, I'm extremely sorry for not writing you a single letter up to now." He was there on his deathbed, and he's apologizing for not writing enough letters. He said in this letter, "I discovered very interesting functions recently, which I call Mach theta functions." So theta functions are a very classical object in mathematics that have been very important throughout mathematics and physics and beyond. And he said he discovered an analog called Mach theta functions. And he says they enter into mathematics as beautifully as the ordinary theta functions. Ordinary theta functions completely transform mathematics. And he's saying on his deathbed that he's found something else that are just as important, called Mach theta functions. So this is often called his deathbed letter. And here's a scan of it, of the letter. We have it. It's kept in the library, in the Wren Library in Cambridge. So you can see some of those formulas at the top. Those are his new Mach theta functions that he said should be just as important as the ordinary theta functions. People stared at that for 80 years and could not understand why they were important. They looked completely random and mysterious. Well, maybe he was ill. People didn't really pay that much attention to it for a long time. But then, in 2002, so it was a mystery until then, but in 2002 there was a PhD thesis of Zweigers in Germany, who showed that Ramanujan had actually discovered a very important phenomenon in mathematics and physics called mass forms. And suddenly these formulas, these were examples, extremely important examples of mass forms. And suddenly they started getting applied everywhere. Once Zweigers wrote his PhD thesis, there's now been a deluge of work on these Mach theta functions of Ramanujan for the last 14 years. And these Mach theta functions, these Mach modular forms, are really living up to his expectations. And just in the last couple years, they found their way into the study of black holes. So when studying entropy of black holes, there was a need for certain functions that satisfied certain properties. And somebody discovered, oh my gosh, the things that Ramanujan had written 80 years ago were exactly what were needed to describe entropy of black holes in string theory. And so this is actually one of the end cards of the film. A century later, these formulas are being used to understand the behavior of black holes. That's one of the final scenes of the movie. So I want to end there. Maybe I'll show you. I'm sure many of you have not. So before I introduce the filmmakers, I thought maybe this trailer is actually now up on the web, so you can search for it. But I thought I'll show you the trailer, and then we'll invite the filmmakers up on stage, and we can talk about how some of these life story elements and mathematical elements were brought to the screen. So let me show you the trailer.
What do you see?
Sad.
Imagine if we could look so closely, we could see each grain, each particle. You see, there are patterns in everything.
In
intervals, infinite series.
I've never seen anything like. From an Indian clerk, ill-educated in Madras, I would very highly value any advice you give me.
Letter for you. Postmarked England.
Yours truly, S. Ramanujan.
What does the S stand for?
You can ask himself.
You intend to invite him here?
Don't forget me.
I could never.
Are you Ramanujan by chance? Oh. Don't be intimidated. Great knowledge comes from the humblest of origins.
For the good of everybody, you should attend some
But
lectures.
I'm here to publish. The letter only contained a small sampling of my discoveries.
This will take a lifetime.
Maybe two.
We need proofs of your work.
But they are right, sir.
I haven't completed that proof. How do you know?
I just do.
You don't pull a stunt like that in my class.
How do you know that theorem?
It came to me. These steps you want, I do not know how to do.
Where do you think you're going? It's our home.
Don't you know what I've given up to be here? I have nothing. You wanted to know how I get my ideas. God speaks to me.
There are no proofs. We're just supposed to take him at his word?
No, you're to take him at mine. Why do you do it?
Because I have to.
There are no proofs that can determine the outcome of matters of the heart. We are merely explorers of infinity in the pursuit of absolute perfection.
I owe you so much.
No, no. It's I who owe you.
Well, it's my great pleasure to introduce to you the writer and director of the film The Man Who Knew Infinity, Matthew Brown. We also have here today the legendary producer. So if you're a film buff, you've of course heard his name. The legendary Ed Pressman is here with us. We also have one of the executive producers with us today, who's actually a Princeton alum, class of '93, Tristine Skyler. And we also have another Princeton alum. So the distributor of this film is IFC. And so from IFC Films, the SVP of the business and legal team is Betsy Rodgers. Class of '95. And well, last but not least, we have the lead actress of the film. She plays Ramanujan's wife, Janaki, Devika Bhise. Well, we thought we'd ask them some questions. And what I thought I'd do is ask, I asked lots of people in Princeton what they wanted me to ask the filmmakers. So I thought I'd begin by asking some questions, and then we can open up to the audience if you have any questions for the cast and crew here. So I want to start with you, Matt, of course. You've done a lot of. Can we hear you?
I think so. Can you guys hear me?
Oh, awesome.
Okay.
Yeah, you've done a lot of writing before, but this is your first feature-length film that you've written and directed. And well, first question everyone wants to know is how you chose the subject. First, how did you learn about this subject, and how did you choose it to make it your first big project? And how did it inspire this dream of yours of bringing the subject to the screen?
Sure. I came across Robert Canigal's book about 10 years through Tristan Skyler, and I was drawn to it for more, I guess, historical reasons. I had just read a book called Bird Song, which was about the Great War, so I was drawn to that period. And then I was drawn to the human relationships. Hardy and Ramanujan were such diametrically, they're just so different. I mean, you know, here you had a person who felt like an equation had no meaning unless it expressed the thought of God, and then Hardy's an atheist, and they just couldn't have been any more different. So I was drawn to the dramatic of that. And then over the years, because it took so many years to be able to get this
How long
filming,
did it take?
10, I'm ashamed to say, it's 10 or 11 years. So over the course of that time, I began to get a better understanding of the mathematics and what that meant, especially to the mathematical community. And I began to see these mathematicians, yourself included, but as artists. And it gave me a different perspective that pure mathematicians were really artists. And I could understand that passion that they had for their subject in the way that I do with writing.
Yeah, that is something that really attracted mathematicians to this movie in the first place, and why the mathematicians that did join your film, we were so, Matt really understood us.
Tried to.
That we, yeah, that we really think of our subject as an art, and that we're pursuing beauty and elegance, and you really brought that to the screen in a way that really excited us, because we finally felt like our subject was being brought in an accurate way.
Please, we tried not to shy away from the mathematics in the film. There's probably more mathematics in this film than other films that deal with quote-unquote mathematical or scientific subjects. And it was a challenge, but hopefully the passion as artists comes through, and it makes it more relatable to people like myself who can barely do the tip at dinner. So.
No, very nice. Well, I wanted to ask Ed a question next, but before I do that, I wanted to tell everyone that today is Ed's birthday. Happy birthday, Ed. We're so grateful that you've agreed to spend your birthday here with us at Princeton. And so I want to ask you the same thing that I asked Matt, which is, well, you've produced so many Hollywood films. You're a legend in the field. What attracted you to this particular film, and how did you meet Matt and get involved? Oh, we have a mic for him? Maybe.
We had a company with can you hear me?
Yeah, that's better. Yeah.
Creative executive in the company, Sophia Sandervan, was
That's good.
basically introduced Matt and I some 11 years ago. I knew nothing about the subject and read the book and early draft of the script that Matt had written, and was taken with it as a great story. But I've always been drawn to films because of the filmmaker. Most of the films that I've worked on are written and directed by one person. I guess, tour theory,
Yeah.
called from French New Wave period. When I grew up in the 60s, film was something that we thought could change the world. We were very affected by a lot of the European filmmakers. Work was seen a lot more than they are nowadays.
Right.
And so I was attracted to the project because of Matt's enthusiasm and his eloquence in discussing it. And we had done a film with Jeremy Irons called Reversal of Fortune that Jeremy had won the Oscar for. So when I introduced Matt to Jeremy, Matt had nothing to show, but he was so convincing and so intelligent about the subject that Jeremy, jumped in, and that was the kind of thing that a great filmmaker has to be able to do, and be able to convince those around him that they're doing something more than just another job.
Right.
So,
Oh, that's wonderful. You're also known in the film industry for encouraging young first-time directors and giving them total creativity, even the creativity to make the final cut. Yeah, can you tell us how and why you managed to do that so successfully with so many directors like Matt? And how you've been able to spot talent like Matt?
I guess I used to have a term called psychological eroticism. It's a kind of thing that I guess the term charisma is another way of looking at it, but it can be shown in a filmmaker like Oliver Stone, who's very bold and out there, or David Mamet, or it could be done very quietly, like David Byrne, Taviani Brothers.
Right.
But there's something about the individual that is also reflected in the work they do, that attracts those around them to believe that they're doing something more than just another job. It's an inspiration. So it's an instinct. It's not something that's calculable.
Right. Yeah, and you have it. Yeah, we've seen that many times with you. Well, maybe I'll ask Tristine. Well, welcome back to Princeton, first of all.
Thank you.
You're on the other side.
It's humbling and my heart is pounding. I never thought I would be on this stage. I only thought I would be in one of those seats forever.
But Tristine is an executive producer of this film. Maybe that's the one thing first to ask, because many in the audience may not be familiar with all these terms: director, producer, executive producer. What are the different roles that these terms imply, and what in particular was your role?
Well,
I think you did a lot more than executive producers normally do. So.
Well, executive producer is a great term because it allows you a lot of freedom to wear a lot of hats. As Matt pointed out, I was part of the original two-person team. I was half of the original two-person team that found this book together and recognized the power of the story. Matt's very gracious, saying that I brought it to him, but it was a joint effort. Over the 10-year development process, I, as executive producer, serve, I guess, to put it in relatable terms, it's sort of a creative partnership or a consultancy for the writer-director through the entire process of writing the script, developing the story, and through all the essential creative decisions that are made over the time that you're trying to make this film, from casting to who your DP is, to your editor. There's so many decisions that are made on a daily basis, and it's a very brave process to go through because it's very hard to get movies made in Hollywood. You probably are aware that Hollywood produces a lot of formula movies and not those kinds of formulas. And this movie is not a formula movie. And so I really credit besides the intelligence and the talent of our writer-director, but the bravery that he had when he stuck with it for so many years and brought it to the screen in such a beautiful way.
We have another Princeton alum here too, Betsy Rodgers, who works for IFC Films, which is the distributor, the U.S. distributor of the film.
And Canadian.
And Canadian.
We are in charge of finding the Canadian distributor.
Right. And maybe you can tell us a little bit about the process of distribution of the film and your involvement.
Well, I wear two hats. I'm both the head of legal affairs and the head of business affairs for the company. And because at IFC Films we have 3 labels: IFC Films, Sundance Selects, and IFC Midnight. And unlike many of our competitors who release, say, 5 to 12 films a year, we release 60, which means that I get to wear a third hat at festivals, which is being a part of the team that goes out and screens the films, and we all come together around midnight and talk about which ones we've seen that day and which ones we think would be a great fit for our company. And I was fortunate enough to be in the first screening in Toronto, although some of my colleagues had gotten a sneak peek at an earlier version. I remember seeing John Katz and sort of sneaking in to the Toronto screening and coming out and
Yeah,
just...
the film actually premiered at the Toronto Film Festival.
Right, and loving it, and then the rest of my team saw it and loved it, and so we come in at the end. We come in after the film's been made, so we don't take as big of a risk as some of these guys, but then we're in charge of making sure that all of you and the whole country sees it on some sort of platform, whether that's in theaters or on television or on your iPad or in a museum, wherever. So that's we're here to bring the film to as big an audience as we can.
That's kind of amazing. As a mathematician, I knew nothing about the film world when I started in this. I'm just amazed at how many people it takes to put this film together. It's only an hour and 40 minutes, the film, and the number of man hours is unbelievably exponentially more than the number of hours that are in the film. One question that everyone wanted to ask you two, just because you are Princeton alums, is how your experience at Princeton led you to do what you ended up doing, and particularly if it's helped you in the jobs that you do. Maybe just a couple words from each of you.
Well, to sum it up, I would say that Princeton encourages brave thinking and exploration. I was an English major, had a lot of classes in here, and I decided to do my JP and my thesis on T.S. Eliot's The Wasteland, with the ultimate goal being to present it as a theater piece where the poem was actually performed in its entirety. And not one person discouraged me, despite the fact that anybody that knows the poem, as Cornel West pointed out to me, if you know the poem well, you know that it takes 10 years to understand that poem. But no one discouraged me, and I think that really exemplifies the spirit of being a Princeton student. You are encouraged to be bold and brave and fearless, and those qualities certainly serve me in the film business.
Well, and I too was an English major, and I received a certificate in American Studies. And then I was also on the business side at the Prince, so that was sort of my way of combining, trying to get some sort of business experience with the creativity of my major. But I also have always been fascinated by popular culture because I see that that is what the majority of this country is ingesting. So I did my thesis on bestsellers, and I focused on 4 genres and went out to show that what was being written about was not only reflective of society, but scarily had an influence on the way people think as well.
Yeah, great to hear that. At Princeton, we often, and even before students come to Princeton, they're often discouraged to major in humanities and arts. And so here are 2 natural role models for people, really successful people who majored.
There really are, the arts are everywhere on this campus. They are everywhere. They're in theater troupes and dance troupes and singing groups, and it's an incredibly creative experience here if you're inclined that way. Yeah. And I do see a connection between this story. I think T.S. Eliot, who I was so intrigued by as a student, I think he would love the story of a mathematician who received his formulas from a goddess.
Absolutely. Yeah, no, the arts here really are amazing. We always encourage the science people as well to take advantage of the amazing arts that do exist here at Princeton. So speaking of which, so we have, last but not least, the lead actress in the film, Devika, Bhise, who portrays beautifully the role of Ramanujan's wife, Janaki. Before I ask you a question, though, we thought we'd show a clip of you, if you don't mind. And just to set up the clip a second, we were just talking about the arts. Mathematicians also view their subject as an art, and this Matt really makes an effort to tell this view of mathematics that mathematicians have, of mathematics really being like an art form to mathematicians. And when Ramanujan first meets his wife, and this is one of his first meetings with his wife, he needs to explain what he does, and he views his subject as an art, and so this is one of his first meetings with his wife, Janaki.
Go ahead. You can knock. Please.
What does it all do?
It's like a painting, I think. Only imagine it is with colors you cannot see.
What good is that?
Not much for you, I'm afraid. But for me, it is everything. Maybe there is someone else who can see and understand it as well. And for them, it will be important.
Have you met them?
No, not yet.
I want to understand more than just colors I can't see.
What do you see?
Sand,
Yes? Imagine if we could look so closely, we could see each grain, each particle. You see, there are patterns in everything. The color in light, the reflections on water. In math, these patterns reveal themselves in the most incredible form.
That's Devika, everyone. Devika, this is also your first feature film. So it's your debut film, and you have to portray quite a wide range of emotions in this, from a new
Mostly
marriage.
just sad.
Well, that is it. You weren't so sad in this particular clip.
Just kidding.
But yeah, you're right. I mean, you have this happiness of a new marriage, learning about mathematics, and then having this separation, and then heartbreak, and reunion, and then heartbreak. Yeah, as you said. Yeah, how did you prepare for this first role of yours, and and then just getting ready to portray this incredible character?
I mean, obviously this was an incredible opportunity, and Matt and I talked a lot earlier about trying to make sure she came across as smart, even though she didn't understand math in that way. She still understood it as an art, and she understood that her husband had a passion and this creative energy about him, and even though she didn't understand exactly what the equations were, she understood that this is something he needed to do, and he was this incredible man. But I also have been studying Indian classical dance since I was 3 years old.
You're familiar with the kind of music that Ramanujan and his family had.
Exactly, and that type of Indian classical dance is from the area in India that this whole story takes place. Because obviously India is such a large place, and here people think India is kind of one thing, and if you go to India or you spend any time there, you realize that north, south, east, west, it's like it's not just one culture. So the type of art that I have been doing for many, many years is from the part of India that this whole, that Ramanujan is based in. So for that I was lucky because I had a leg up.
You had to fit in that mold.
To fit in
of
that
the South
mold,
Indian
yeah.
culture.
And
Right.
even when it came to the way you walk or hold something or talk, or that all came from my training in that art, because obviously who I am is pretty
far off from the character in the movie.
Right. No, that's beautiful. Maybe a more lighthearted question for you. I know that you and the other actors, Dev Patel and Jeremy Irons, used to joke around about how much of the mathematics you understood or didn't understand that was being portrayed in the movie. Who among you three was the best at following mathematics? Or the least best?
Dave was the least best. I took a lot of math in school, actually, so I got a lot of it, but then, I got like 3/4 of your lecture, so,
That's very good. Well, as many of you know, A Beautiful Mind was filmed here at Princeton, which was about our beloved colleague in the mathematics department, Professor John Nash. And so he was here during the filming of the movie about him. And we used to often ask him, well, how do you feel about this Russell Crowe portraying you, given that he's had essentially no experience in mathematics? And his reply was, well, Russell Crowe was never a gladiator either, but he did pretty good with that. So good actors can portray anything, and the three actors here really got into the minds of mathematicians. They used to ask us questions that we never even thought about. Things like, when you're doing a proof, what is the most exciting moment for you? Is it when you have the idea, or is it when you're writing it down, or is it when you've written that final line? These are things that mathematicians that we were being consulted on this, we were thinking, wait, we never even thought about that. We just do it. And actors really have to go in and figure out when is the moment of excitement and when is the moment of just deep thought and not thinking about those emotions. So great actors can do anything, like Russell Crowe and like the actors that are here in this movie. Maybe it's a good time to open up questions for the audience. Yeah, please. Maybe we have mics that maybe we can.
Sir, you alluded to the importance of universal education. So several decades passed from Ramanujan's time. How much progress do you feel that we have made as a society in identifying unbelievable talent, perhaps in unexpected places?
We've made some progress, but not nearly enough. We're very far from getting there. One of the things that the producers of this film had an idea on was to use this film as an excuse to try and locate talent in the world. And so there's this new initiative called the Spirit of Ramanujan, and there's a global search for talent that's being launched. And it can be found at xpii.com, EXPII.com, where children all over the world can go and do math puzzles. And xp.com xp.com, EXPII.com/Ramanujan. And if you go there, encourage children to go there. That's a source where lots of children all over the world will be able to network. If they have talent in mathematics, they will be able to network, solve puzzles, and there's a winners list that keeps track of the daily activities on there and who's at the top. One of the math consultants for this film was Ken Ono, who was number 3 on the list for a long time. And we're like, why are you participating in this? But he's like, no, it's just to encourage other people. But he's dropped now. He's only number 10 now. So yeah, I encourage you to do that. But lots of initiatives like this are needed. This is one really good one that we're really proud of. But the universal education, we're still so far from it. Even in the United States, we still don't always find all the talent. But in countries like India, there's so much incredible talent there, and we lose it every year because there's no way for us to find it. And the story of Ramanujan really shows it easily could have happened that he would have passed through the cracks too. And there was just one mathematician that happened to see his talent among the dozens of letters that he wrote. So we do really have a long way to go, and his story really shows us that. But there's a long way to go. And that's why this movie is very timely. It's to remind us that we really need to do this and get moving. Okay, maybe you?
The trailer is beautiful. Can't wait to watch the movie. there's a lot of material on Ramanujan and his life. I'm pretty sure you did a lot of research, especially my question is for you, Matt. About the cultural appropriateness, sorry, I'm presuming that you're not from Kumbakonam, so could you share some of your experiences researching the cultural appropriateness of a plot? The Tamil culture, how did you, are there any interesting experiences that you can recollect, that you can talk about?
How did you go about understanding Tamil culture in order to make this movie that takes place, about somebody who comes from there?
Well, the first thing I had was Robert's book, which was a pretty great introduction into Ramanujan. Beyond that, Swati Bhise was a cultural advisor on the film. We had a cultural advisor that was very helpful in trying to understand the culture, but also everything down from the costumes to all the little intricacies of that. Beyond that, I'd done a couple of trips to India, and I'd spent a lot of time trying to immerse myself in other texts besides Man Who Knew Infinity. I'd read a number of articles and papers. Robert Canigal was really kind to me when I first got into this, and he opened up all of his research to me. So I spent a lot of time reading Indian accounts of Ramanujan's life, and I've had books and books and books and books. And then I've watched everything I could watch in terms of other documentaries. We tried to do right by this film. And it's one of those things that took a long time to make because in many ways I refused to make it in a way that wasn't going to be authentic. I tell the story, but it's really quite true that I had been offered financing on an occasion if I would just have Ramanujan fall in love with a white nurse at Trinity. So it was as simple as that. And I could have made this movie 6 years ago with a little love scene or two. So it was important to me, you can't do everything exactly right, but we really did try. So.
Very good. Okay, well on that note, we're out of time, but we'll stay a few minutes if you want to come up and ask us questions personally for a few minutes. We're so grateful for the cast and crew to have joined us on this occasion. When I asked them if they'd want to come to Princeton, they said, Princeton? We never get invited to Princeton. And I was here, I was thinking, why would they want to come to Princeton? So we're so grateful that they joined us here for this event. Thank you so much. I just want to tell you that the movie will be opening on the 29th of April in select cities and making its way to theaters. Please do spread the word. Take your friends to see the movie if you like what you see, and please spread the word. Thank you so much.